Chapter 4 Quadratic Equations. An equation of the form ax square plus bx plus c equals to 0. Here, the polynomial expression ax square plus bx plus c equals to 0. Only if it equals to 0 we call it as an equation. An equation is something which is equals to something. Generally in mathematics we equate every expression equals to 0. Here the criterion is that a should not be equals to 0. If a equals to 0, then the equation turns into bx plus c equals to 0, which becomes a linear equation. So a should not be equals to 0. In the first question, which of the following is not a quadratic equation? The first one is a quadratic equation, second is a quadratic equation, and the third is 3 plus x square is quadratic equation. Here in option B, it's x square plus x cube plus 2 equals to 0. So it is cubic equation. Option B is not a quadratic equation. Question number 2. The quadratic equation has degree. The quadratic equation has always degree of 2. So option C. Cubic equation has degree 3 and the biquadratic equation has degree 4. The polynomial equation is, so we need to check if the equation is linear, quadratic, cubic. So before that, let's solve this. This is x square plus x plus 8 equals to x square minus 4. It is of the form a plus b into a minus b. On both the sides, x square gets cancelled, so x equals to minus 12. So it is a linear equation. Option A. Next, question number 6. The equation is a. The equation contains x square plus 4 minus 4x plus 1 equals to 2x minus 3, which contains the x square term. If the equation contains x square term, definitely it's a quadratic equation, no matter even if it is not having the 4x or even if it is not having the constant. It is a quadratic equation. Option B. The roots of the quadratic equation are. So the roots are, here the sum of the roots alpha plus beta equals to minus b by a, that equals to 1 by 6. So check the options. Alpha plus beta equals to 1 by 6 and alpha into beta equals to c by a, which is minus 2 by 6, that equals to minus 1 by 3. This gives you the product as minus 1 by 3 and the sum of the roots equals to, the sum of the roots is not satisfying. Here the sum of the roots equals to 4 minus 1 by 6, yeah. It's 4 minus 3 by 6 equals to 1 by 6. So option C is satisfying the given two conditions. The quadratic equation whose roots are 1. So there's a printing mistake here. We'll skip this question. The quadratic equation whose one rational root is 3 plus root 2 is. Generally, these kind of roots like 3 plus root 2 surds exist in pairs. If 3 plus root 2 is a root, then definitely 3 minus root 2 is also a root. These are called as conjugate pairs. So x minus of 3 plus root 2 into x minus of 3 minus root 2. This forms our quadratic equation. But no need of solving this. We can simply say that alpha plus beta equals to 6 and alpha into beta equals to 9 minus 2, which is equals to 7. So from the given options, alpha plus beta equals to, we need to get 6. So option D gives you correct answer. Alpha plus beta equals to minus of minus 6 and alpha into beta equals to 7. Question number 10. The equation 2x square plus kx plus 3 equals to 0 has two equal roots, then the value of k is. So we have the equal roots, so delta should be equals to 0, discriminant. B square is k square minus 4 into 2 into 3 equals to 0. So k equals to square root of 24. That is 2 root 6 plus or minus 2 root 6. Option D. Question number 11. The roots of the quadratic equation x plus 1 by x equals to 3 are. So given equation is x plus 1 by x equals to 3. This is x square minus 3x plus 1 equals to 0. Applying the quadratic formula, minus b is plus 3 plus or minus root, b square is 9, minus 4 is minus 4 into 1 into 1. So 4 by 2 into a is 1. So it gives 3 plus or minus root 5 by 2. So 3 plus root 5, 3 minus root 5 by 2. Option C. The roots of the quadratic equation 2x square minus 2 root 2x plus 1 equals to 0 are. So this is alpha plus beta equals to 2 root 2 by 2, which is equals to root 2, and alpha into beta equals to 2. So option B gives sum of the roots as root 2, but the product is half. Even for the option B, the sum of the roots equals to 2 root 2, which is not satisfying. I'm sorry, this alpha into beta equals to, it's 1 by 2. So option A satisfies. So the sum is 1 by root 2 plus 1 by root 2, which equals to same denominator, which is root 2, and adding the numerators, it's 2. So 2 by root 2 equals to root 2. This is root 2 times. And the product equals to 1 by root 2 into 1 by root 2 is 1 by 2. Next question is 13. The sum of the roots of the quadratic equation 3x square minus 9x plus 5 is. So sum of the roots equals to minus b by a, which is minus of minus 9 by 3, which equals to 3. Option A. If the roots of ax square plus bx plus c equals to 0 are in the ratio m is to n, then, so given the ratio of the roots m is to n, let us say alpha and beta are the roots, and alpha by beta equals to m by n. So alpha plus beta equals to minus b by a, alpha into beta equals to c by a. From here alpha equals to m by n into beta. Substitute the value of alpha here. That implies m by n into beta square equals to c by a. And substitute the alpha value in the first equation, which gives m by n into beta plus beta equals to minus b by a, taking out beta common and taking the LCM, m plus n by n, that equals to minus b by a. So beta equals to minus b into n by a into m plus n. Substitute the value of beta in this equation. So let me erase this first. So here we have m by n into beta square, right? So m by n into beta square is b into n by a into m plus n whole square, which equals to c by a. One n from here, one n here gets cancelled. One n here, one n here, and one a here, one a here gets cancelled. So multiplying b square into mn by a into m plus n equals to c, and m into n into b square equals to m plus n of ac. So this is the condition. Mn into b square equals to m plus n into m plus n whole square into ac. Square is left here, which is option C. Next question is 15th question. If one root of the equation x square plus px plus 12 equals to 0 is 4, while the equation x square plus px plus q equals to 0 has equal roots, then find the value of q. So this is the given equation. So one root is 4, while the equation has equal roots. So here discriminant equals to 0, which is p square equals to 4q, and from the first equation 4 is the root, that implies 4 square plus 4p plus 12 equals to 0, and this is 16. 16 plus 12 is 28. 4p equals to minus 28, p equals to minus 7. The value of q will be p square, 49 by 4. So it is 49 by 4, option A. 16th question. A and p are the roots of the given equation, then find the value of 1 by alpha plus 1 by beta. So these are the reciprocal roots. Alpha plus beta equals to minus 3 by 4, and we have alpha beta equals to c by a is 7 by 4. We need to find 1 by alpha plus 1 by beta, that equals to, taking the LCM, it is beta plus alpha by alpha beta, that equals to ratio of these two, that is minus 3 by 4 by 7 by 4. 4 gets cancelled and you get minus 3 by 7, option B. The next two questions are incorrect, we'll just skip those questions. 19th question. If alpha and beta, this is beta, if alpha and beta are the roots of the equation whose roots are 1 by alpha and 1 by beta. The equation with the roots 1 by alpha and 1 by beta is x square minus sum of the roots is 1 by alpha plus 1 by beta into x plus 1 by alpha beta equals to 0. From this equation, alpha plus beta equals to 3 by 2. So here this is alpha plus beta by alpha into beta into x plus 1 by alpha beta equals to 0. So alpha plus beta equals to 3 by 2 and alpha beta equals to 6 by 2 is 3. Taking the LCM and substituting the value of alpha beta, this is 3. So taking the LCM, 3x square minus alpha plus beta equals to 3 by 2x plus 1 equals to 0. Multiplying 2, 6x square minus 3x plus 2 equals to 0. This is the required equation, which is option 1, option A. Next, question number 20. If the roots of the given equation are reciprocal of each other, then. So if one is alpha, the other will be 1 by alpha. The product will be 1, that equals to 2 by p. So p equals to 2. Option D. Question number 21. If one root of the quadratic equation is 2, the value of k is. So one root of the quadratic equation is 2. The value of k we need to find. So it is 2 into 2 square plus 2k minus 6 equals to 0. This is 8 minus 6 plus 2k equals to 0. K equals to minus 1. Option B. The roots of the quadratic equation 1 by a plus b plus x equals to 1 by a plus 1 by b plus 1 by x. So this is the given equation. Instead of solving this, let's try to substitute the values. In the option A, I have a comma b. So if I substitute the value of x as a, I will get 1 by 2a plus b. That equals to 1 by a plus 1 by b plus 1 by a, which are not equal at all. If I go to option 2, I have 1 by minus a comma b. If x is minus a plus b minus a, these two gets cancelled, and 1 by a plus 1 by b plus 1 by minus a, these two gets cancelled. So 1 by b equals to 1 by b. But the other root is b, which is not satisfying. For the other root to be satisfying, I should have x equals to minus a comma minus b. So even if x is minus b, I'll get 1 by a on left hand side and 1 by a on the right hand side. Next is 23. The roots of the equation 7x square plus x minus 1 equals to 0 are. So find the discriminant, which is equals to 1 square minus 4 into a is 7 and c is minus 1. That equals to 1 plus 28. So this is positive. So when the determinant is positive, the roots are real and distinct. The equation 12x square plus 4kx plus 3 equals to 0 has real and equal roots if. So we need to get real and equal roots. This is possible when b square equals to 4ac. Discriminant equals to 0. So 4k whole square equals to 4 into 12 into 3. 16k square equals to 4 into 12 into 3. So 4 times, 4 3 times, k equals to plus or minus 3. Option A. 25th question. If minus 5 is root of the quadratic equation, then the value of p we need to find. The substitute the value of minus 5 here. This is minus 5 whole square is 25. 25 into 2 is 50. X is minus 5, so minus 5p minus 15 equals to 0. So 5p equals to 35, p equals to 7. Option C. If the roots of the equation are simultaneously real, then so for the first equation 2b whole square equals to 4ac, that is b square equals to ac. And for the second equation 2 root ac minus 2 root ac whole square equals to 4 into, here a is b and also c is b, so 4b into b. This is 4ac equals to 4b square. So in both the cases I got b square equals to ac. Option B is the answer. Question number 27. The roots of the equation are equal, then find the condition. So for this, b square equals to 4ac, which is c minus a whole square equals to 4 into b minus c into a minus b. Here we are going to get complex equation which is of the formula a plus b plus c whole square. So for CBSE 10th class this is not required. For this the answer is c plus a equals to 2b. Let's try to cover this question. Question number 28. A chessboard contains 64 equal squares and the area of such each square is 6.25 cm square. A border round the board is 2 cm wide. The length of the side of the chessboard is. The chessboard is having 64 equal squares, in the sense each side contains 8 squares by 8 squares. So it's a chessboard of 8 by 8 squares, and around this there is a border which is of 2 cm wide. This is 2 cm wide. Let x be the side. Since we have 8 squares, one square will be x by 8 units, x by 8 centimeters. The area of one square equals to x by 8 into x by 8, which is given as 6.25. So from this, x square equals to 6.25 into 8 square, x equals to square root of 6.25 into 8 square, which gives square root of 6.25 is 2.5 into 8. This is 2.5 into 8. This is 20 centimeters. So x is 20 centimeters, and the width is given as 2 centimeters here and 2 centimeters here. The total length of chess will be 20 plus 2 plus 2, 24. So option C is the correct answer. Next is 29th question. 1 year ago, a man was 8 times as old as his son. Now his age is equal to the square of his son's age. The present ages are. Let us first divide the time. This is present. This is past. This is son. This is father. So in the past, if son is x, the father will be 8 times of x. And in the present, Since the data is given as 1 year ago, the present will be x plus 1 and this will be 8x plus 1. Now his age is equal to the square of his son's age, in the sense 8x plus 1 whole square, 8x plus 1 equals to square of the x plus 1 whole square. So in present, the father's age is square of the son's age. We need to solve this equation. This is 8x plus 1, that equals to x square plus 1 plus 2x. X square, 1 gets cancelled. Minus 6x equals to 0. X into x minus 6 equals to 0. So x equals to 6. We need to find the present ages. So this data is about the present ages now. So in the present, son's age is x plus 1, that is 7 years. And the father will be 57 years. So the present ages are 7 and 57. Next question. The sum of the squares of two consecutive natural numbers is 313. Then the numbers are. So given that the sum of the two consecutive natural numbers, let's say x comma x plus 1 are two consecutive natural numbers. The sum of the squares is x square plus x plus 1 whole square equals to 313. This is x square plus x square plus 2x plus 1 equals to 313. So 2x square plus 2x minus 312 equals to 0. I'm dividing with 2. X square plus x minus, this is 1, 2 1 times is 1, 256 times, so this is 0. So this is my quadratic equation. So product of roots equals to 156. It will be x plus 13 into x minus 12 equals to 0. X equals to 12 or x equals to minus 13. But we want natural numbers. So x equals to 12 is the solution. If x equals to 12, then the other number is 12 plus 1, which is 13. So option A is the answer. Next, 31st question. Which of the following is not a quadratic equation? Option A contains 2 into x minus 1 whole square, which contains the x square term. Option B contains x square term. And option 4, if you look at option 4, if you expand this, it is x power 4 plus 4x square plus 4x cube equals to x power 4 plus 3 plus 4x cube. So x power 4 gets cancelled. 4x cube gets cancelled. So I have 4x square equals to 3, which is a quadratic equation. But coming to option C, in option C I have a square as root 2x whole square, which is 2x square, and also have this x square, which adds to 3x square. 3x square on the left hand side and the 3x square on the right hand side gets cancelled and forms a linear equation. So option C is not a quadratic equation. Next question 32. If x minus a is one of the factors of the polynomial, then one of the roots of ax square plus bx plus c equals to 0 is. So x equals to a is one of the factors of the polynomial. That implies a cube plus ab plus c equals to 0. And one of the roots of ax square plus bx plus c equals to 0. If I take out a common here, a square plus b plus c equals to 0. If I substitute 1 in the equation, I have a plus b plus c equals to 0. If I substitute c, ac square plus bc plus c equals to 0. And if I substitute a, so I have a cube plus ab plus c equals to 0. So it's trying to relate the polynomials and the quadratic equations. X equals to a is one of the factors of the polynomial. So obviously a is called as the root in the quadratic equations. That's the only difference. In polynomials, a is called as the 0 of the polynomial, and in quadratic equations it is called as the root. 33rd one. Which of the following are the roots of the quadratic equation? So here it's by factorization. Generally in MCQs we can follow any method, but let us do by factorization. We need to split the number 20. So 5 into 4 is 20. I want minus 9, so minus 5 minus 4. X square minus 5x minus 4x plus 20 equals to 0. X into x minus 5. Minus 4 is common, so x minus 5 equals to 0. If I take x minus 5 as common, x minus 5 into x minus 4 equals to 0. X equals to 5. 34th question. If 1 minus p is the root of the equation, then the roots are. So given 1 minus p is a root, so substitute the value of 1 minus p in the place of x, p into 1 minus p plus 1 minus p equals to 0. In the entire equation I can take out 1 minus p common. So here it is 1 minus p plus 1 equals to 0. Minus p plus p gets cancelled. 2 into 1 minus p equals to 0. So p equals to 1. P can be 1, or if I solve this, I'll get if p equals to 0, my root is 1. So if p equals to 1, 1 minus p equals to 0. So the roots are 1, 0. Next 35th one. If a, p roots of the given equation, then equation whose roots are a plus 1 and b plus 1 is. So for this, sum of the roots a plus b equals to minus 5 and a into b equals to 5. And the equation whose roots are a plus 1 and b plus 1. Whenever we add these two roots, we'll get a plus 1 plus b plus 1. That equals to a plus b plus 2, which is minus 5 plus 2. That is minus 3. So the sum of the roots is minus 3. That contains in option B and C. And the product of the roots will be a plus 1 into b plus 1. So a plus 1 into b plus 1 equals to ab plus a plus b plus 1. So ab is 5 and a plus b is minus 5 plus 1. So product of roots will be plus 1. So option C is the answer. Next, 36th question. Which of the following equations has two distinct real roots? So b square should be more than 4ac. The first equation, it is 3 root 2 whole square, which is 9 into 2 is 18. Should be more than 4 into a is 2 and c is 9 by 4. So 18 is more than 18, no. And in option B, b square is 1 and 4ac will be 4 into a is 1 and a is minus 5. So 1 is more than minus 20. So this is correct. So option B is the answer. 37th one. Which of the following equations has no real roots? So b square is less than 4ac. Where we get imaginary roots. In the option A, b square is 16 and 4 into ac is 4 into a is 1 and c is 3 root 2. 16 is less than, this is 12 into root 2. Squaring on both sides, 16 square is 256 less than 144 into 2. So 144 into 2 is 288. So which is correct. So option A, b square is less than 4ac, which contains imaginary roots. 38th question. X square plus 1 whole square minus x square equals to 0. So this I can split it as x square plus 1 plus x into x square plus 1 minus x equals to 0. So this is of the form a square minus b square. I just split it into a minus b into a plus b form. So this contains imaginary roots. This expression here contains imaginary roots. So our biquadratic equation contains only two real roots. Option B. Thirty-ninth question. If the difference of the roots of the equation be 1, then so given that alpha minus beta equals to 1, we have alpha plus beta equals to b and alpha into beta equals to c. So I can say that alpha plus beta whole square plus, or else we subtract these two, alpha minus of alpha minus beta whole square equals to 4 alpha beta. That is alpha plus beta is b square minus this is 1 equals to 4 into c. So b square minus 1 equals to 4c, or b square minus 4c equals to 1. So it is option C, b square minus 4c minus 1 equals to 0. Next, 40th question. In the 40th question, if alpha plus beta equals to 4, alpha cube plus beta cube equals to 44, then a comma p are the roots of the equation. So this is not a comma p, this is alpha comma beta. So alpha plus beta equals to 4. It is possible only in the option C. 41st question. If the roots of the equation are of opposite sign, then which of the following cannot be the value of p? So they are of opposite sign. So if b square equals to 4ac, then we don't get this opposite signs, we'll get equal roots. So b square is 2 square and 4 into a is 3, c is p plus 2 into p minus 1, which is p square plus p minus 2. This is 4, this is 4 gets cancelled. 1 by 3 equals to p square plus p minus 2, or 3p square plus 3p minus 6 equals to 1. 3p square plus 3p minus 7 equals to 0. So factorizing will get 3p square. We need to split minus 21 as 7 and minus 2. 3p square plus 7p minus 3p minus 7 equals to 0. 3p of p plus 7 minus 1 of p plus 7 equals to 0. So p equals to minus 7 or p equals to 1 by 3. So these two can't be the value of p. So it's minus 7 comma 1 by 3. So in this question the option is not given, but the answer is p equals to 1 by 3 or p equals to minus 3. Next question, 42. The value of k for which the equation has equal roots is, so this is b square equals to 4ac, that is 2 into k plus 1 whole square equals to 4 into ac is 4k square. So on expanding this is 4 into k square plus 4 plus 8k equals to 4k square. So k equals to minus 1 by 2. Option B. 43. If the equation x square minus 2 plus m of x plus is constant equals to 0 as coincident roots, then so it's talking about the coincident roots. So 2 alpha equals to 2 plus and alpha square, the product of roots equals to minus m square minus 4m minus 4. So alpha square equals to 2 plus m by 2 whole square, that equals to minus m square minus 4m minus 4. So on expanding this, 4 plus m square plus 4m equals to minus 4m square minus 16m minus 16. This is 5m square plus 20m plus 20 equals to 0. And dividing with 5, m square plus 4m plus 4 equals to 0. So this is m plus 2 whole square. So m equals to minus 2 comma minus 2, which is option C. Next, 44th question. If x equals to 2 is the solution of the given equation, then the value of k is. So just substitute the value of 2, which is 4 minus 10 plus 6k equals to 0. 6k equals to minus 6. Minus 6 goes to that side, which is 6k equals to 1. So answer is 1. Check whether the following are quadratic equations. So first one contains this x square here, and x square here gets cancelled, but x square here is there, so it's a quadratic equation. This is not a quadratic equation because x square gets cancelled each other. And third one is x cube minus 3x square plus 5x. That is a minus b whole cube, which is a cube plus b cube plus 3a square b minus 3 into a into b square. So this x cube and this x cube gets cancelled, and we have the quadratic equation. So it's a quadratic equation. Even this is quadratic equation. This is cubic equation. And this is a quadratic equation. If x equals to minus 2 is the solution of the equation, so we need to just verify this. So minus 2 whole square, minus 2 into minus 2 plus 8 is 4 plus 4 plus 8. So x equals to minus 2 is not a root. 47th one. If x equals to 3 is one of the quadratic equation, one root of the quadratic equation, then find the value of k. T square minus 2k into 3 minus 6 equals to 0. This is 9. 9 minus 6 is 3. 3 equals to 6k, and k equals to 1 by 2. So the answer is 1 by 2 for this. Forty-eighth one. Are x equals to 0 and x equals to 1 the solution of the equation? So these two are not the solutions of the given equation. Actually, for this we'll get imaginary roots. So we'll be getting imaginary roots which are not real. So this is not necessary for you now. Next, Ruchir was asked his age by his friend. Ruchir said, the number you get when you subtract 25 times my age from twice the square of my age will be thrice your age. If the friend's age is 14 years, then the age of Ruchir is. The number you get when you subtract 25 times my age from twice the square of my age is. Twice the square of age. From this, if you multiply 25 times his age, will be getting twice the age of his friend, which is y. If the friend's age is 14 years, so y is 14 years, so 2x square minus 25x equals to 14 into 3. So 14 into 3 is 52. Then the age of Ruchir, find the value of x. So we need to solve the quadratic equation. 2x square minus 25 minus 52 equals to 0. So minus 52 into 2. Minus 52, the factors are 13 into 4, 13 into 8, no, 13 into 4 into 2, 13 into 2 into 2 into 2. This is 13 into this is 42. So this is 42 into 2. 42 is 21 into 2. So the factors are 21 and 4. So this is 42. So minus 21 comma minus 2x square minus 4x minus 21x minus 42 equals to 0. Taking 2x common, x minus 21 is common. So x minus 2 equals to 0. X equals to 2 comma 21 by 2. So coming to the next question, which is 50th question. The number of integral values of x so that 2 power 2x square minus 7 plus 5 equals to 1 is. So 2x square minus 7 plus 5 should be equals to 0. This will be 1 only when we have 2 power 0. So 2x square minus 2 equals to 0 and x square equals to plus or minus 1. So x square equals to 1 and x equals to plus or minus 1. So these are the integral values of x. So these are the 50 questions from the quadratic equations. We'll do some more MCQs from the next chapters.